You have this worksheet right in front of you, and it's great practice. If you look at the back, all the answers are there. Please let me know if I made any mistakes on the answers. But anyway, it's great practice. I expect you to do all this to prepare for the test tomorrow. In a little while, I will give you a practice test that mirrors the test itself, all right? But before we actually give you that practice test, we have this missing portion that we haven't covered yet, which is adding and subtracting fractions, rational values. Now, in order to add or subtract a fraction, you need a common denominator, okay? So, number one, we already have a common denominator in both. So it's the easiest thing in the world to add fractions when you have a common denominator, because your answer will be just simply adding the numerator with the numerator and keep it over that same common denominator. So 2/4 is your answer. Now, whenever you do have an answer that's a fraction that could be reduced, please reduce. So that final answer should be 1/2 if you reduce by 2. So I hope everybody follows along right here as we are practicing adding and subtracting fractions. So number 2, what's the common denominator going to be? 4, right? So if it's not already the same, go to your bigger denominator and see if you could change your smaller one to become the bigger one. So like, let's say this would have been a 5, and you can't change 2 to become a 5. Take that 5, then multiply it by 2, and then see if you could change it to that. But anyways, right now the 2 could be changed to a 4 by simply multiplying both top and bottom by 2. So the new denominator will be 4. And this denominator over here was already 4. And 2 on top times 1 on top is 2 up on top. And there's still a plus sign between them. And since we didn't do anything to this denominator, we're not going to do anything to the numerator. So 1 right there. Now that we have a common denominator, we could actually add the numerator with the numerator and giving us a final answer of 3 over that common denominator 4. 3/4 is your answer. So sometimes you'll have a common denominator. Sometimes you'll be able to change one of them to look like the other. And sometimes you're going to have to change both of them. Like right here. The 2, you can't change it to a 5, right? So what do? Go to the bigger one and first multiply it by 2. What do you get? 5 times 2 is 10. Could you change that to become a 10? Yes. So the common denominator is 10. So I like to take my fractions, these guys, and just write them right below right here with the new common denominator. So I put a 10 down here and a 10 down there. Now the question is, how do I change the 2 to become 10? Multiply by 5. Whoa, that didn't work. Multiply by 5. And what you do to the bottom, you must do to the top. Multiply by 5. So up on top, I get a 5 over 10. Now that makes total sense because 5 over 10 is really 1/2. Now over here, how do I change the 5 to become a 10? Multiply by 2. So you multiply the top also by 2. So up on top, you end up with 2 over 10. Now it's still a subtraction problem, but now that we have a common denominator, we could write our answer over that common denominator. And what is 5 take away 2? 3. There's your answer, 3/10. Okay? Let's jump to number 6. So this is obviously not a common denominator. They have no common denominator. You need to actually find that common denominator. So the question is, could you change 6 to become 8? You go to the bigger one and you say, could you change 6 to become 8? The answer is no. What if I took 8 and multiplied it by 2? What would the answer be? 16. Could I change 6 to become 16? With multiplication, no. So multiplying by 2 didn't work. How about multiplying by 3? 8 times 3, what's that? 24. Could I change 6 to become 24? Yes, right? So the common denominator will be 24, and that's what we call the LCD. Now you could have just said, oh, multiply them both together. 48 is my common denominator, 48 is my common denominator. But you end up with bigger numbers. So the advice I give to you guys, and what I always do, is I look at the bigger denominator, and then I multiply it by 2 and then see if I could change that to that answer. So 8 times 2 is 16. Could I change 6 to become 16? No, I can't. 8 times 3 is 24. Could I change 6 to become 24? Yes, I can. So that's why I put 24 on both. Now let's actually go through those changes. 8 times 3 is 24. 7 times 3 is 21. 6 times 4 is 24. 5 times 4 is 20. All right, only one person's following along. That's not good. We are subtracting between the two. So what's my answer going to be? Definitely over 24. 21 take away 20 is 1. There's your answer, 1 over 24. So it's that easy, guys. Well, it's not that easy. I mean, it's way easier to multiply fractions, right? You just multiply top with the top, bottom with the bottom, or you could cancel things out before multiplying. But it's that easy when you're adding or subtracting fractions, you need a common denominator. Let's take a look at number 7. I recommend changing a mixed number into an improper fraction, especially if you're subtracting, okay? So how do we change a mixed number to an improper fraction? Let's take some notes if you don't remember. What you do is you take this 3 and you multiply it. Multiply by 2, all right? And then you add the 1 to it. And you keep it over that common denominator, or over that original denominator, 3. Okay, so 3 times 2 is 6, plus 1 is 7. So 2 1/3 is really 7/3. So what I have here is 5 take away 7/3. Now, in order for us to add or subtract fractions, what do we need? A common what? Denominator. So if we look at that 5 and say, okay, 5 over 1. Are these denominators the same, 1 and 3? No. So what's my common denominator going to be? 3. Okay, so right below each of those fractions, let's put that common denominator 3 with the minus sign right between them. How do I change the 1 to become a 3? Multiply by 3, multiply by 3. That's how we get 15 up on top. And that makes total sense because 15 divided by 3 really is 5. I just rewrote it, made it look like a fraction. Okay. And then over here, the 3, we don't do anything to it. So the 7, we're not going to do anything to it. So that's really still a 7 right there. Now that we have a common denominator, we could actually subtract 15 take away 7. What is 15 take away 7? 8. 8 over 3 is your final answer right there. 8 over 3. Now, that's totally acceptable, but let's say you're taking a midterm and it's multiple choice and you don't see that answer there. They might have changed that back to a mixed number. So 8 divided by 3, that'll go in 2 times. When you subtract, that'll give you a remainder of 2. As a matter of fact, the remainder I'm going to put in green. And it always works out like this. Your answer, the 2, with the fraction that has the remainder 2 over the original divisor 3. So 2 2/3 is the same thing as 8/3. So either one of those is good. So we have a whole page of practice and all the answers are on the back. We could practice this stuff, check your answers on the back. That way you could be better prepared for tomorrow's test. Now the best way to be prepared for tomorrow's test is to work on the practice test itself. So this is almost identical to tomorrow's test, all right? The only difference is I'm going to delete 3 questions. So instead of 33 questions, you're going to have 30. But the first part of the test will be classifying real numbers. So number 1, 3.25. Is that a crazy decimal that you don't understand? No, that makes sense. What do we call that decimal? Rational. Rational. Any fraction or decimal that makes sense, we call it rational. Let's move on to number 2. What would you classify -2 as? Integer. That is a nice negative number. If it had a fraction or decimal, it would go back to rational. Number 3, that could be tricky. A lot of people say irrational because they see that square root sign, but it's actually natural. Why is that? You actually have to classify the answer. What is the answer to the square root of 25? 5. So the number 5, what is that? That's a nice natural number. You learned how to count all the way to 5 when you were young, right? 1, 2, 3, 4, 5. That's natural. Number 4, that is what? Rational. It's a fraction. Any fraction or any decimal that's not crazy, you're going to say that it's rational. It's okay if it has a negative sign. It's still a fraction. It's still a ratio. It's still rational. How about that guy? Whole number. That's right. If you include the 0, it's the number with the biggest hole in it. That's why it's a whole number. How about the square root of 7? That's irrational. Why is it irrational? Because if you do this on the calculator, it'll give you a crazy decimal number that continues forever, that has no pattern. It's just crazy. It's irrational. So that's the first part of the test. I hope everybody aces that first part. The next part is ridiculously easy if you know your rules to adding, subtracting, and multiplying integers, right? First thing to know is when you're actually multiplying, which means you're remembering the rules that a negative times a negative is a positive. And when you're thinking of money. So are we thinking of money on number 7? Yes. Yes. We're thinking of money on number 8? No. Thinking of money on number 9? Yes. Thinking of money on number 10? No, because there's no sign between them. Thinking of money on number 11? Yes. So whenever there's a sign between your terms, you got to think of money, right? So number 7, I need to think of money. I owe 4, I owe 5. What's my answer? I owe 9. Negative 9 is the right answer. This next one, I am not thinking of money because there's no sign between the 4 and the parenthesis. So yeah, 4 times 5 is 20, and a negative times a negative equals a positive. So positive 20 is the answer there. Number 9, before thinking of money, I must change the minus minus to plus plus. Okay? So now I can think of money. I owe $4. What does this mean? I have $5. Could I pay him off? Yeah, I'll actually have $1 left over. Positive 1. Number 10, am I thinking of money? No, because there's no sign between the parentheses. That means you're multiplying. So 4 times 5 is 20. A negative times a positive equals a negative. So negative 20 is your answer right there. Number 11, last one on this section. 4 take away 5. We are thinking of money. 4 means that you have $4. Negative 5 or minus 5 means that you owe $5. You cannot pay them off. What's your answer going to be? Negative 1. Give a decimal approximation for the following. In order to be good at doing a decimal approximation, you should write your perfect square number list. So there's my perfect square number list. Again, just say 2 times 2, that's how you get 4. 3 times 3, that's how you get 9. 4 times 4, 5 times 5, and so on and so on. You get your perfect square number list. Now, once you have this list, now you can look at this square root of 91 and see where would it land. It would be pretty close to what? 181. It's in between, right? Now, here's the question. Is 91 really close to 81? Is it really close to 100? Or is it pretty much in between, in the middle? In the middle, right? So here's the deal. I need to know that that belongs pretty much perfectly in the middle of those two answers. So if I did take the square root of 81, that's 9. If I did take the square root of 100, that's 10. My answer has to be pretty much in the middle. So what's the middle? 9.5. 9.5 is the answer to number 12. 9.5. And you should put the approximation symbols, the little squiggly equal sign, because it's not exact. Okay, so how about this one, 143? Where's that at? Is it between two numbers? Yeah, it's between the 121 and the 144. Now, is it pretty much in the middle, or is it really close to 121, or is it really close to 144? That's right, it's really close to 144. So if we think about this, what is the square root of 144? 12. So the square root of 143 has to be a little bit less than 12. So what number is a little bit less than 12? 11.9. So there's your answer for this guy, 11.9. Converting percents to fractions, those are easy. Free points. What do I mean by percents to fractions? You see, per cent means per 100. The root word cent means 100. There's 100 cents in a dollar. There's 100 years in a century, right? The word cent means 100. So per cent means per 100. So 40% is really 40 per 100. And that's it. That's your answer. You guys remember that? However, if you leave it like that, you only get half credit, because anytime you have a fraction as an answer, you should try to reduce it. The zeros cancel, and the 4/10 could be reduced by 2, and you'll get the final answer 2/5. Now, number 15 You guys think that's easier or more challenging? What does 17% really mean? 17 over 100. Could you reduce 17 over 100? Nope. So it's actually easier. Bless you. I said easy you. Bless you. Easier. Number 16, convert the following decimals to fractions. All right. How do we change a decimal to a fraction? We need to remember this, guys. The place value of the numbers. So the 1 is technically in the tenths place. The 7 is in the hundredths. If you had another number right here in that box, that would be the thousandths. So all you do is write the number that you got over the position of the last digit. So this as a fraction is going to be what? 17 over 100. Could we simplify that? No. So we're done. Now, if I would have had a 3 right here, then I would say 173 over 1,000. That's right. How about this guy right here? How do we write that as a fraction? 5 over what position is it in? 100. That's right. It's in the hundredths position. Now, could we reduce 5 over 100? Yeah. Reduce by 5 becomes 1 over 20. So there's your final fraction for that, number 17. Now this is probably the most challenging section of the front side of the test tomorrow. Convert the following fraction into a decimal and then into a percent. Okay? So how do we change a fraction into a decimal? Division, right? A fraction is really a division problem. So 3/8 is really 3 divided by 8. Now, of course, 8 times what gets you close to 3 without going over doesn't work. So that's why we put the decimal right there. So when they say convert to a decimal, that's where we throw in the decimal. That way it looks like 30, and of course the decimal will be up here. So let's say 8 times what will get us close to 30 without going over? 8 times 3 is 24, and that's good. It won't go over. Let's actually subtract. 30 take away 24 is what? 6. And then we add a 0 and then drop a 0. And now we have 60. 8 times what gets us close to 60 without going over? 8 times what?
7.
8 times 7 is 56. So let's put a 56 right here and let's subtract. 60 take away 56. 60 take away 56. 4. Now, you're probably thinking, man, this is taking forever. Will it go on forever? No. If you add a 0 and drop a 0, you get 40 right there. And 8 times 5 is 40. And when you subtract, you have no more remainder. Finally, we've converted 3/8 to the decimal 0.375. Or you could say 0.375. Now, they didn't say for us to write the decimal answer. They said convert it to a decimal and then to a percent. What do we do to convert this decimal to a percent? Move it over 2 places where? To the right. So move it 1, 2, and here's your decimal. So here's your answer as a percent, 37.5%. Okay, let's move on to this last one. How do I convert that to a decimal? What goes inside the division box?
5.
The 1 goes on the inside and it's divided by 5 on the outside, right? So you add a 0 to make it look like 10. And yeah, that decimal is going to be up here. And 5 times what is 10? You're going to say 2, right? And we're actually done right there. So 1/5 is really 0.2. So let me write that out, 0.2. But they don't want the decimal, they want the percent. Move it to the right 2 spaces. So 1 space, 2 space. Here's your decimal. Fill in the spot with the 0. So as a percent, it's really 20%. So that's the entire front side of the practice test. It's going to be almost identical to the actual front side of the test tomorrow. Let's look at the back side of the practice test. Now, right here is where we have adding, subtracting, multiplying fractions. So on number 20, we are subtracting fractions. Is that easy or is it difficult? Why is it easy? It already has 16 as a common denominator. So 7 take away 4 is 3. 3 over 16, there's your answer. right there. Multiplying is always easy. It's even easier when you could cancel. Right here, you can't cancel, so just go 2 times 4, get 8. 5 times 7, get 35. And since you weren't able to cancel at the start, that means that you're not able to reduce. So there's your answer for 21. 22. What do we do when we divide by a fraction?
We
Switch the division to what? To multiplication.
And we switch the one half.
Yeah, switch that second fraction to become a 2 over 1. It's the reciprocal, right? And that first one's going to stay the same. 3 over 2 stays 3 over 2. I don't flip it. And then multiply. But what could he do before multiplying that'll make it easier? Yeah, cancel the 2 on top with the 2 on the bottom. Now multiply, you get the answer 3 over 1. Or just 3. But there's the answer number 22. 23. We have 2 fractions. The denominator is not the same. We need a common denominator. So some people are going to say, I'm just going to multiply both of them together. My common denominator will be 150. Put a 150 here, 150 there. I don't recommend that, right? I recommend going to your bigger denominator and multiplying it by 2. What do you get? What's 15 times 2? 30. Could I change 10 to become 30? Yeah, so that's my common denominator. My LCD will be 30 by going to my bigger one and multiplying it by 2 and testing that number. So the common denominator is 30. I'm going to have to change both of them to 30. There's still a minus sign between the two. The first fraction, multiply it by 3, multiply it by 3, you'll get 21. The second fraction, multiply it by 2, multiply it by 2, you get 8. So our final answer, 21 take away 8 is 13. And that will be over the common denominator 30, and there's nothing else to do. You can't reduce it. 24, we're dividing by a mixed number. Let's change that to an improper fraction first. How do I do that? 3 times, right? Times 1, and then plus 1. So what's 3 times 1 plus 1? 4. And it's going to be over the original divisor 3. So I really have 11 over 12 divided by 4 over 3. But we do switch that to a multiplication, and then switch the second fraction, will be 3 over 4, and you'll have the 11 over 12 right in front. Then you just multiply or cancel. It's up to you. You guys want to multiply first and then reduce, or cancel first and then multiply? You see that 3 up on top and that 12 on the bottom? They're both divisible by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So it's easier to cancel that first and then multiply. 11 times 1 is 11. 4 times 4, 16. You cannot cancel the 4 with the 4 because they're both on the bottom. You can't cancel it. So you got to multiply them actually. So there's your answer, 11 over 16. $25. What's our common denominator going to be? Could you change 6 to become 8? No. All right, so take the bigger denominator, multiply it by 2. What do we get? 16. Could I change 6 to become 16? No. So multiply it by 3. What's 8 times 3? Could I change 6 to become 24? Yes. So 24 is your LCD, lowest common denominator. How do you get 24? 8 times 3 gave us 24. 3 times 3 gives us 9. 6 times 4 gives us 24. 1 times 4 gives us 4. 9 take away 4 is 5, and it's over that common denominator 24. Nothing else to do. There's your answer. 5 over 24. Could I cancel anything here before multiplying top with top, bottom with the bottom? What could I cancel? 20 and 10. If you reduce both by 10, 10 divided by 10 is 1. 20 divided by 10 is 2. What is a negative times a negative? Positive. So your answer is going to be what? 2 times 3, which is 6. And 11 times 1, which is 11. And a negative times a negative is a positive. There's your answer for number 26. Bless you. 27. Before thinking of money, I need to change the minus minus to plus plus. Not only that, to add or subtract fractions, you need a common denominator. What will my common denominator be? 12. Right, here's your bigger one. Could you change the smaller one to look like the bigger one? Yes, by multiplying by what? 4. By 4. So I want that denominator 12. I want that denominator 12. This is already 12, so I don't have to do anything to it. So I'm not going to mess with this fraction. It's going to be negative 1/12. I only need one plus sign. I don't need to put both of them down here. 3 times what gives us 12? You guys said 4. Multiply by 4, you're going to get 8 up on top. So now that you have a common denominator 12, you could actually do the negative 1 plus 8. Negative 1 plus 8 is what? 7 over that common denominator 12. On the practice test, it's actually positive, because if you think about owing $1 and having $8, you'll have 7 left over after you pay them off. 28, is there anything I could cancel? The 9 and the 18, right? They're both divisible by 9. 9 divided by 9 is 1. 18 divided by 9 is 2. So you can now actually multiply top with top. A negative times a positive is a negative. So you're going to end up with a 1 up on top, 8 on the bottom. There's your answer, negative 1/8. On the practice test, we have this list where I want you to organize it. To save time on the test, I'm just going to skip that one, so you don't have to worry about that. Let's jump to the final section of the test tomorrow, which is dealing with exponents. And there is a big difference when you have parentheses and when you don't have parentheses. When you have parentheses, these parentheses are technically including that negative sign when you expand. So negative 5 in parentheses squared, if I expand it, it'll be a negative 5 times a negative 5, which makes it, final answer, what? Positive 25. And number 32, when you have negative 5 without parentheses squared, technically that's telling you to expand 5 squared, which is 5 times 5, and you simply take that negative sign and put it in the front. So you really have a negative 5 times a positive 5, which makes it, final answer, negative 25. So parentheses do make a difference. So right here, it is in parentheses. So the question is the answer going to be a positive one or a negative one? Positive. Why is it positive? Because it's an even degree, even power, right? Which means that if I were to expand it, negative 1 times negative 1 times negative 1, 28 times, I'll be able to pair them all up. If it's even, it's divisible by 2. I'll be able to pair them all up, which makes them all positive. So positive 1's your answer. Likewise, if I had negative 1 to the, let's say, 103rd power, what answer would you have there? That'd be a negative 1 because it's an odd number. You wouldn't be able to pair up all of them. Okay. But then again, if I had negative 1 to the 8th power without parentheses, what would the answer be? That would actually be negative 1, because the negative will go in front, and then you'll have the 1 to the 8th power, 1 times 1 times 1, 8 times. Final answer will be negative 1. Anyway, that's the entire test explained to you. Tomorrow's test will be practically identical to this test.